Okay, so now that we know those derivatives, let's take a look. If I look at back of the x squared graph, if I evaluate that derivative at x equals 2, right, I'm dealing with 2 times 2, which is 4. On the other hand, if I switch and look at the derivative of the inverse, I can't evaluate it at x equals 2 because the corresponding point, right, the x value is actually 4. And so when I look at that, then that would be 1 over 2 times the square root of 4, which would be 1/4. Okay, let's take a look at these two answers for a second. Is there a relationship between them? Do you have a guess of what might be going on when I look at the derivatives of inverses? Okay, so is there a relationship here? Remember, it means that we're looking at the slopes of the tangent lines. Since they're a reflection over the line y equals x, there probably should be a relationship there. Okay, and it turns out that they are reciprocals of each other. Okay, so let's think of another point. So like for instance, if you know that the ordered pair 3, 9 is on f of x, right, which it has to be because this would represent the x value and x squared would be 9, do we know what ordered pair would be on its inverse? And the answer is yes. Okay, then 9, 3 is on the inverse graph. Okay, and so my question for you is, let's see if that actually holds in terms of its derivative. So we're kind of expecting reciprocal answers again. Okay, so if I evaluate the derivative of the function at x equals 3, I get 6. Okay, and if I evaluate the inverse derivative, okay, I can't evaluate at x equals 3. Now I have to evaluate at x equals 9 because that's the x value of that point there. I get 1 over 2 times the square root of 9, which is 1/6, and lo and behold, your conjecture above does